Now let's continue our example using the same discrete PDF and think about variance and standard deviation. So variance of x comes from taking the sum of x squared times p of x minus the expected value that we got squared. So variance, after it's square rooted, becomes standard deviation, and standard deviation helps us think about how variable the outcomes will be from week to week in the case of our breakdowns of the machine. So I'll change colors here for a minute so we can keep track that this is what I'm going to compute right now. I'm going to compute x squared times p of x. So notice the probability is not squared, but the x is squared. So 0 squared is 0. 1 squared is still 1. So we have 1 times 0.2. 2 squared is 4. So 4 times 0.35 is going to give us 1.2, and 3 squared times 0.3 gives us 2.7. So once again, we need to sum the column, and we'll get 4.1, and that is the sum of x squared times p of x. So 4.1 is that initial part, and then we subtract off what was the expected value of x, or the mean of x that we already had was 1.8 breakdowns on average per week, which gets squared, and the final answer becomes 0.86 is the variance of x. In order to convert it to the same units as x itself, we need the standard deviation of x. Standard deviation of x, which is always the square root of the variance of x, which is the square root of 0.86. And I realize it's not here, which is 0.927. So that is the standard deviation of x. And sometimes the symbol for standard deviation is a lowercase sigma, and for variance is sigma squared. So we'll see that notation in the future. So that is how to compute the standard deviation and the variance of a discrete random variable.